Okay, so let's take a look at our next example here. We're on examples. Is it D, I think? We have x equals the square root of x plus 7. That is our radicand inside our radical. Then we have this plus 5 on the outside. Remember, once again, our whole goal is to isolate, right? We want to isolate that radical. So we need to get rid of that positive 5. And we get rid of that positive 5 by subtracting 5 to both sides. Doing that leaves us with x minus 5 equals the square root of x plus 7. Now that our radical is isolated, we can go ahead and take both sides to the power of 2. Right, because that will cancel the radical and that exponent. So on the right side, we're left with x plus 7. But on the left side, we have x minus 5 and another x minus 5. We go ahead and distribute again, right? That's x squared. That's a minus 5x, another minus 5x, and a plus 25. Bring the right-hand side down. We combine our like terms. So x squared minus 10x plus 25 plus x plus 7. And it's quadratic, so once again, we subtract x, subtract 7 to set our equation equal to 0. So get x squared minus 11x plus 18. And we factor. All right, we're looking for the product of 18. That sums to give us negative 11. We see that to be a negative 2 and a negative 9. So we get x minus 2, x minus 9 equals 0. All right, and then from there you can set each one equal to 0 and solve. And then we add 2, we get an answer of 2. Add 9, we get an answer of 9. And once again, we want to check our work. Right, we have an answer of 2. We have an answer of 9. And our original problem was x equals the square root of x plus 7 plus 5. So we replace. We get 2 equals square root of 2 plus 7 plus 5. All right, 2 plus 7 gives us 9. The square root of 9 is 3. And we see that we get 8, so this is no good. All right, and we do it again. This time we replace x with 9. Uh, 9 plus 7 gives us 16. Square root of 16 is 4. And we see that this does work. So here we get one answer. We get an answer of 9. So a nice example there. How about we have 2 radicals? Square root of x minus 3 plus another square root x plus 5 equals 4. So 2 radicals. So let's just isolate one of the radicals. Let's say I'm going to get this x minus 3 by itself, okay? I want to get x minus 3 by itself. So if I want to get that by itself, I have to get rid of this one. And I do that by subtracting x plus 5 to both sides. The square root of x plus 5. So now we get the square root of x minus 3, all right, equals 4 minus the square root of x plus 5. So we're working with this one. We want to get rid of that radical, okay? So now let's go ahead and just like we did before, we take this to the power of 2, take that to the power of 2. This radical and that cancels, so we're left with x minus 3. We can't cancel them because here we have a binomial, so we have to show two of them. And we got a FOIL. We have the FOIL here. 4 times 4 is 16. 4 times this negative square root of x plus 5 is just a minus 4 square root of x plus 5. And now we have this one that we're going to distribute there is also a minus 4 square root of x plus 5. And now we do both of those, negative and negative makes it a positive, right, square root of x plus 5. And we have two of them, right? So it's to the power of 2. All right, so let's take a look. We bring down our x minus 3, bring down our 16. We can combine these. They're like terms. Minus 4 is a minus 8 square root of x plus 5. All right, plus now here we see the fact that we got this square root and this power of 2. They cancel, so now we're left with just x plus 5. Okay. So what we want to do next is we want to get this radical by itself. So let's, what can we do here? How about we do 16 plus 5? Let's start there. 16 plus 5 gives us a 21. Okay, now let's get rid of 21 by subtracting 21. Let's get rid of x by subtracting x. Cancels. Even here, x minus x cancels. Negative 3 minus 21 is a negative 24. That cancels. We're left with negative 8 square root of x plus 5. All right, so this is something that we, problem that we saw a little earlier. We can really start isolating here. I see that I can divide these two numbers very nicely. So I'll divide by negative 8, divide by negative 8. That will cancel. Negative 24 divided by negative 8 gives us a 3. All right, so now we really simplified this problem quite a bit. It looks really nice. We want to get rid of the radical. So once again, we have to do this again. Take this side to the power of 2. Take that 3 to the power of 2. For 9 equals, those cancel, x plus 5. Next step, subtract 5, and we get x to equal 4. And after you check your work, you see that that would be a correct solution. So example E, a really nice example, definitely one that has quite a bit of work. Let's take a look at another example like that. I think I like this last one. Let's take a look at example F. Looks like some factoring will come into play with this problem. I got the square root of x plus 2, right, minus the square root of 2x plus 2. Then we got plus 1 equals 0. So the same kind of idea, let's try to isolate a radical. All right, let's try to isolate a radical here. So why don't I don't like this minus sign, I'm going to get rid of it. How about I add the square root of 2x plus 2 to both sides? Add the square root of 2x plus 2 to both sides. More than one way of doing it. I'm just doing it this way here, but you could approach it a different way as well, and it should work out. I'm kind of switching it up. This time I'm putting my radical by itself on this right side, opposite to the previous example. All right, so I am going to get this, eliminate this one. All right, so take it to the power of 2, come over here, take that to the power of 2. This is a binomial, so I got to show 2 of them. And here, radical and power of 2 cancel out. So just like before, this radical times that radical, they're both the same. So I'm going to show that power of 2 there. Now, this radical times 1, well, it's just 1 square root of x plus 2. We got 1 times the next one, it's just plus 1 times the square root of x plus 2. Then we got 1 times 1, it's just 1, right? And we bring down our 2x plus 2. And if you feel like I'm going fast, by all means, go ahead and pause it and understand the step before you continue, all right? Square root power 2 cancel out. We combine these two, right? All you're doing is doing 1 plus 1. So that's plus 2, square root of x plus 2. Bring down our plus 1, and we bring down our 2x plus 2. What can we do? 2 plus 1, right? So now we got x plus 3 plus 2 square root of x plus 2 plus 2x plus 2. All right, we want to get this by itself now, so I subtract x, subtract 3. Subtract x, subtract 3. Cancels, we're left with 2 square root of x plus 2 equals 1x minus 1. Here, if I divide by 2, divide that whole thing by 2, I'm left with the fraction. I don't like that, so I'm not going to do that. I'm going to do what we did a little earlier in the previous example. Right, I'm just going to take this whole thing to the power of 2 and this to the power of 2. Keeping in mind that we're doing it to this and to the radical, right? This is a monomial. All right, so that 2 is having the power of 2, square root of x plus 2 is having the power of 2. And over here as well, we got to show 2 of them because this is a binomial. Monomial, 1 term, binomial, 2 terms. So this gives us 4 cancels. We're left with x plus 2 here. So again, we distribute or FOIL. All right, we're left with 1x times 1x is 1x squared. 1x times negative 1 is minus 1x. Negative 1x times negative, or times 1x is a negative 1x. Negative 1 times negative 1 is a positive 1. We distribute 4x plus 8. We bring down our 1x squared. We combine those. We get minus 2x plus 1. And quadratic again, right? So we set it equal to 0. Minus 4x minus 8. Minus 4x minus 8. Cancels. 0 equals 1x squared minus 6x. And 1 minus 8 gives us a negative 7. So again, factor. Product of negative 7. That sums to give us a negative 6. What do we get? Negative 7 times 1. That works out, doesn't it? So it's 0 equals x minus 7 and x plus 1. All right, now we can set each one equal to 0. And we get an answer of 7, and we get an answer of negative 1. And after we check it, and I'll let you check it on your own here. If you have questions about checking, let me know. But you see that we only get one answer to be correct. X equals 7. So nice examples here. As we can see, this section 6.6 definitely has quite a bit of problems to practice. I would be comfortable with all these examples. And if you have any questions, by all means, let me know, or one of the assigns.